Click the bell icon to get latest videos from Ekeeda.
Hello friends, in the last video we have seen a few problems on conversion of NFA to DFA. Now in this we will continue with similar problem with quite complicated questions. Let us see the first one. In this we are going to start with NFA which accepts set of all strings which starts with 1 0 and convert that NFA to DFA. As you can see, in the NFA, we have used three states Q0, Q1 and Q2. Q0 on 1 have a transition to Q1 and then a 0 have a transition to Q2. Once we have a transition to Q2, we have already seen the symbol 1 and 0. That means our string starts with 1, 0. And after that, we need not consider the string further. Now, let us transform the given NFA to the transition table. We have drawn the transition table. Q0 or 0 has no transition, hence it is represented using the null symbol. Q0 on 1 has a transition to Q1. Q1 has transition to Q2 on 0 and Q1 has no transition on 1. Similarly, Q2 has transition to Q2 itself on both symbols 0 and 1. We know that Q0 is the initial state, hence we represent that in the table. Similarly, Q2 is the final state. Now we transform the table of NFA to a DFA. Q0 has a transition of dead state on 0 and Q0 has transition to Q1 on 1. In the first row, we have encountered a new state and hence we will have a new entry. Q1 has a transition on 0 to Q2 and Q1 has no transition on 1. Again, we have encountered a new state Q2. We will have to insert the transition for the same. With this, we are done with the transition table for the NFA as we are not encountering any new states further. Now we will have to symbolize the final and the initial states. Let us try to draw the DFA using the table. We can see the transitions in the DFA now. Q0 is the initial state. Now on 1 it will have a transition to Q1, on 0 it will have a transition to Q2, and now all the symbols are ignored because we have already encountered 1 followed by a 0. That means our string starts with 1 0. Any string which starts with 0 will encounter the dead state, and any string which has 1 as the second symbol will again go to the dead state. Let us name our machines M4 and M4 cap. Let us see their mathematical definitions. For M4, Q will contain Q0, Q1 and Q2 as their states. Sigma is the alphabet containing the binary alphabet 0 and 1. Delta is a transition function for the NFA. Q0 is the initial state, and F is the final state which contains Q2. Similarly, for M4 cap, here Q cap will contain the state Q0, Q1, Q2 and null, that means the dead state. Sigma has the alphabet 0 and 1. Delta is a transition table for DFA. Q0 is the initial state and final state F will contain Q2. Now let us see one more example of conversion of NFA to DFA which accepts set of all strings which contain 10 as a substring. Let us try to construct the NFA for the given problem. As you can see in the diagram, Q0 is the initial state, Q2 is the final state. On encountering 10, we have a transition from the initial state to final state. That means this will accept the set of all strings which contain 10 as a substring, or we can say the string will contain 10 in it. Let us try to draw the transition table from the given NFA. Let us try to draw the transition table from the given NFA. Q0 on 0 has a transition to Q0. Q0 on 1 has transition to both Q0 and Q1. Q1 has a transition to Q2 on 0 and Q1 has no transition on 1. Q2 has transition on to Q2 on both 0 and 1. Now we will transform the NFA table to a DFA transition table. We know that Q0 is the initial state. Q0 has a transition to Q0 on 0 and it has transition to both Q0 and 1 on 1. Now in the table we have seen a new state Q0 combined with Q1. Now I will write the transition for this combined state. Q0 has a transition to Q0 on 0. Q1 has a transition to Q2 on Q0. Q0 has a transition to Q1 on 0 and Q1 has a transition to Q2 on 0. So we will combine the states. On 1 we have only one transition, that is from Q0. As we have encountered one more new state, we will add the new state in the given entry. We will combine the rows of Q0 and Q2. We get one more state Q0, Q1, Q2. We will combine the rows of these states to get the given DFA row. Let us try to draw the DFA. Q0 is the initial state. Draw करो and explain करता हूँ. We have transformed the given transition table to the diagram. As you can see, Q0 is the initial state. On 1, as you can see, Q0 is the initial state. On encountering 1 after followed by a 0, we will go to the final state Q0, Q2. Similarly, now after any symbol 0 or 1, after any symbol, now on any symbol 0 or 1, we will see that constantly the string is in final state either Q0, Q2 or Q0, Q1, Q2. This DFA accepts the same set of strings which is accepted by the NFA, that is strings containing 1, 0 as a substring. There are two redundant states, Q0, Q2 followed by Q0, Q1, Q2. In elimination of redundant state, we will see how to reduce these states and to get the DFA with minimal number of states. Now let us see the mathematical definition of these two machines. Let's name this machine M5. Let's name this machine M5 cap. For machine M5, Q is a set of states. Here it is Q0, Q1 and Q2. Sigma is the alphabet containing binary 0 and 1. Delta is a transition function. Here it is a transition table for the NFA. Q0 is the initial state and F is the final state. Here it is Q2. Similarly, for M5 cap, similarly in M5 cap, we have Q cap, sigma, delta cap, Q0 and F cap. Here Q cap is a set of states which are Q0, Q0 and Q1, Q0 and Q2, Q0, Q1 and Q2. Transition function delta cap is a transition table for the given DFA. Initial state is the set containing Q0 and final set is the set of all states which contain Q2 because Q2 is the final state of given NFA. Here it is Q0 and Q2, Q0, Q1 and Q2. We have seen the conversion of NFA to DFA for two cases. One is a set of strings which starts with 10, set of strings which contain 10 as a substring. Now we'll see one more category, set of string which contains 10 at the end. Let us first draw the NFA. As you can see, this NFA contains three states Q0, Q1 and Q2. This accepts set of all strings which ends with 10 because it is waiting on Q0 unless it is not reaching 10 as a final symbols. Now let us draw the transition table from the given transition diagram. In the transition table, you can see that Q0 has a transition to Q0 on 0 and Q0 has a transition to both Q0 and Q1 on 1. As you can see in the table, Q0 has a transition on Q0 on 0 and Q0 has transition to both Q0 and 1 on symbol 1. Similarly, Q1 has transition on Q2 on 0, but there are no transition on Q1 on 1. Q2 has no further transition, hence in Q2 you will see that there is null symbol for both 0 and 1. That means Q2 has transition to dead state on both 0 and 1. We know that Q2 is a final state, so let us mark the final state Q2. Once we completed with the transition table of NFA, let us now translate this table into a DFA. Once we are done with the transition table of the NFA, let us now convert the NFA table to a DFA one. Here, Q0 has a transition to Q0 on 0 and Q0 has transition to both Q0 and Q1 on 1. Now we have encountered a new state Q0, Q1. Now we will add this entry to the transition table. Let us see the NFA table back. Q0 and Q1 have transition to Q0 and Q2 on 0 and Q0 and Q1 have transition to Q0, Q1 and dead state on 1. We will add this information to the DFA table. As we can see in the table, we have encountered one more new state, Q0, Q2. Now we will add entry for Q0, Q2. In the NFA table, Q0, Q2 has transition to Q0 and null on 0, Q0, Q1 on 1. We will add this information to our DFA table. As you can see, there are no new states. We can terminate our process of creation of DFA table. Now let us try to draw the DFA. We have drawn the DFA from the given table. As we know that Q0 is the initial state in our NFA, as we know that Q0 is the initial state in our NFA and Q2 is the final state in our NFA, Q1 will be the initial state in the DFA and any state which contains Q2 will be the final state. Over here, Q0, Q2 is the state which contains Q2, hence that will be the final state. This DFA accepts the same language which was exactly accepted by the given NFA, that is the set of all strings which ends with 1 0. As you can see, it will accept 1 followed by 0. As you can see, this DFA will accept the same strings which was accepted by the given NFA, that is the set of all strings which ends with 1 0. Here you can see it will accept the string 1 followed by 0, or let's say string 1 1 0. That means any string which has 1 0, any string which has 1 0 at the end. Now let us see the mathematical definition of these two machines. Let us name this machine M6 and let us name this machine M6 cap. As you can see, for M6, Q is a set of states, which is Q0, Q1 and Q2. Sigma is the alphabet 0 and 1. Delta is a transition function for Nfa. Q0 is the initial state. F is the final state, which contains Q2 in this case. Similarly, for M6 cap, we have Q cap, sigma, delta cap, Q0 and F cap. Out of them, Q cap contains a set of states over here, Q0, Q0 and Q1, Q0 and Q2. 0 and 1 is the alphabet sigma. Delta cap, the transition function. Delta cap, the transition function for DFA. Q0 is the initial state. F cap contains the set of states which is final. Here it is Q0, Q2 because Q2 was the final state of the NFA. With this problem, we have finished with this category of problems. From the next video, we will be solving more complicated problems on conversion of NFA to DFA. Thank you for watching this video. Stay tuned to Ekeeda. Do subscribe to Ekeeda.